What we're going to learn today is how to persist the tasks that we put into our task manager in a local SQLite database so that they are there between app restarts and phone reboots and crashes and anything like that. And that is a useful tool to put in your Android toolbox. So let's just go over quickly what we did last week. Last week we added this list with these checkboxes, so now I can get a nicer view into the list of all the tasks that I have, and I can also manage which ones are complete. So if I remove these completed ones, now I just have one task left for today, and I hope to be able to click this off pretty soon. So that's what we've done so far. Now today, what's a little bit interesting is that we're not going to see any difference in the view. So let me take you through what we'll be doing today. We're going to be building out the third iteration of our task manager, and we're going to be adding persistence. So to do that, I'll need to talk you through a little bit of SQL. Let's get a quick kind of poll from the audience. Who has never used SQL before? SQL, Structured Query Language, I think it's called.
Looks like everybody in our live audience in Seattle has used SQL. And we'll wait a second for online responses.
I've got one not. Have not.
Okay.
Two have nots.
So it sounds like most people have.
I have nothing in the chat room, so I'm assuming everybody's tried it in the chat room.
Here we go. We got about another not and 3 yeses.
Okay, good. Well, that doesn't seem like there's too many people that haven't, but that's not. I'll give you all the code that you need, and you can use this as a jumping off point later on to go learn some more about SQL if you find that SQLite database on your Android app is an important feature. But I'll also kind of give you a nice overview, which will help out and act as a refresher for anybody who it's been a little while. Then we're gonna jump into actually building out using SQLite in our application. And that will be at 4 different parts, and anybody who's used SQL before knows this is kind of like the CRUD steps, which is an acronym that database people use to describe really standard interactions with data that follow the pattern of creating, reading, updating, and deleting. So they talk about that as CRUD. So we're going to CRUD some tasks today. That means get all the tasks out of the database that are in there right now, and that'll be when the app starts up. And then we'll add a task the way we added a task before, but except there'll be one extra step where we put it in the database. And then when we click off a task as being complete, we'll have to update that task, or the other way around. Whenever that completeness changes, we'll update the task, and then we can delete tasks too. So adding persistence. The user stories that we're going to be working with in this iteration are exactly the same as they were before. There's nothing different about that. You still want to get all the tasks. You still want to add tasks into the application, mark a task complete, remove a task. So from kind of a user-facing perspective, and also at least in the 2 cases where we get tasks and add a task, this is what's known as refactoring. So let me just talk about that really quick. If you've never heard that, refactoring is you can read this quote. It's an idea that came up in a book that Martin Fowler wrote. Martin Fowler is one of the I don't know, sort of an elder in the programming community, right? Somebody that we all look up to. He's this real smart guy, and he talks about the pattern of refactoring code, which is where you take code that works a certain way and you change some underlying characteristics or the underlying implementation so that things are much better structured and cleaner and easier to maintain, but the API or the interface stays the same. So in a couple cases, we have we'll show how we've got a good design here, since everything is going to go through the task manager application to do things. A lot of the code is not going to change and it doesn't care if the tasks are stored in memory as they are now or in the database as they will be when we're done. So you'll see a little bit of that that design coming to fruition as we work through the things that we go through today. As we go through the code, we're going to be running into two new classes that we'll be working with. One is a SQLite database, which is a Java class that wraps a local SQLite file. SQLite is a very nice and lightweight database that's implemented in C and uses a file to store its data that's easy to sort of ship around and use in a lightweight application type of an environment. So it's really well suited for mobile development. It's not a big database server that you're going to run in production, but it's an ANSI compliant database that you can ANSI SQL compliant, which means it's a standard implementation, and it runs nicely in memory. So it's good for devices especially. And Android ships with that capability, so you know you're going to have access to a SQLite database if you're working with Android. And the way you get access to it is through a SQLite database class. And the way you make it easy to access and work with that SQLite database is through something called a SQLite Open Helper, which makes it easy to deal with the database in a couple of different common states, which is like, say your application is just starting off, you won't have a database created unless you choose to ship with a database. But in either one of those cases, the SQLite Open Helper will figure out if the database exists for you and create it if it's not existing. And if it doesn't exist, it will give you some callbacks that allow you to set some things up, and it also gives you a way to manage different versions of the database so that you can upgrade databases as you upgrade your application for customers that already have your app installed.